Welcome everyone to the study guide review video for the 8th grade Unit 6 test. Question 1. Here is a scatter plot. Which equation fits this data? So we have a scatter plot and then we have a line of fit for the data, and we're trying to say which of the equations of the line what's the equation of the line that's graphed there. Okay, key thing, a huge idea in 8th grade math is knowing we can write the equation of any line in slope-intercept form. Y is equal to the slope of the line times x plus the y-intercept. Y equals mx plus b. So in order to pick the right answer here, we just need to find the slope and the y-intercept of the line. The y-intercept is generally pretty easy. That's where the line crosses the y-axis, and that is happening here at 2. So we should have plus 2, not plus 6. And then we need to find the slope of the line. And to find the slope, you create 2 points, or you pick 2 points on the line, and you create a slope triangle. Okay, it's important that you pick points that are on the line, right? Not like the dots or the points around, right? We're talking right now about the line, not about the actual data points. Okay, and then to find slope, you take the height of the slope triangle, or the rise, or the vertical change, divided by the base of the triangle, or the run, or the horizontal change. People use all different words for that. You have to be pretty careful in this graph, though. It's an easy mistake to make, even though I guess it doesn't end up affecting your answer if you're paying attention. But the height here is just 1. Well, I guess actually it's really -1 because we're going down. But it looks like 2 squares, right? But we're counting by halves in it. So we're just going from 0 to 1. That's a change of 1. But then on the x-axis, we're counting by 1. So this is 1, 2, 3. So our slope is going to be -1/3. And right, you just have to know that it's negative, not positive, because our line is going down. We have a negative association. So our answer is A, because it has the right slope and the right y-intercept. All right, question 2. Zola gathered data to see if there was an association between wearing lucky socks and winning at chess. The number of chess players who did not wear lucky socks and won is missing from the table. Zola found there was no association. About how many chess players who won did not wear lucky socks? Okay, so if we have no association, that means that the percent of people who won should be about the same, regardless of whether they wore their lucky socks or not. So that means we're going to have about equivalent ratios, or percents, right, between the different categories. So yeah, a couple different ways you could do this. I guess how I would do it quickly, just looking at it, is I would say, okay, there were 18 people who won who had lucky socks, and then there were 6 people who lost who had lucky socks. That's 3 times as many people. Sorry, in that direction, 3 times as many people. So if there is no association, we have an equivalent ratios, so there should also be 3 times as many people who won and did not wear lucky socks, and there were just like more people in general who won. So you do 5 times 3, which is 15. So you want to, the best way, fastest way to figure this out is this equivalent ratios idea. But then we can check our work by thinking about the totals. So based on this, there's 15 as our answer. There's 20 people total who did not wear lucky socks, and there's 24 people who did wear lucky socks. And we can calculate that 15 out of the 20 who did not wear lucky socks won. That's going to be 75% if we do 15 divided by 20 in a calculator. And then we have that 18 out of 24 people who wore lucky socks did win, and that is again 75%. So basically what we just confirmed is that 75% of people who wore Lucky Socks won, and 75% of people who did not wear Lucky Socks also won. So since the percentage is the same, there's not an association. Okay, none of that work is necessary. It's just a good way of like checking your work. But it's a multiple choice question, so if you answer B, you get it right anyway. All right, question 3.1. Draw a scatter plot that includes at least 6 points, a negative linear association, and one obvious outlier. So we need a scatter plot, so we don't have a line, we just have points. And the points are going to be generally going in a negative direction. So the points are going down, and also generally linear. So it's not a perfect line they're making, but it's a good estimate is it's around a line. And then we need one obvious outlier, so 1 point that's far away from the rest of the points. Okay, so anything like this would work. Theoretically, those should be the same size, but whatever's fine. Okay, and then 3.2, we need at least 6 points in a positive nonlinear association. Sometimes people struggle with coming up with something that's nonlinear. That means it is more of like a curved shape. I mean, there's a couple different ways to do it, but it's like here and then like kind of quickly we start to go up like this, right? If you were to draw a good approximation of it, it would look more like this, like an L or curve, and not a line. Okay, so ultimately it needs to be going up, right? Like in general, versus looking like it's going down, but it needs to not do that as just like a straight line. Question 4. Select all of the pairs of variables that have a negative association. So a negative association means as one variable increases, so like as x increases, the other variable y decreases. Okay, so we're looking for which of these two things, these two variables, would have that sort of relationship in the real world. So for the first option, as minutes you have walked increases, is it true that the number of calories burned decreases? No, that's not true. The more you walk, the more calories you burn, so that would be a positive association. As one increases, the other also increases. Okay, the next one, as time spent studying increases, test scores also increase. So that is what would happen. Test scores would also increase. So this is a positive association, not a negative association. The more you study, the better you do, right? In general, on average. So this is a positive association, not a negative one. For the next one, as the number of people in a checkout line increases, is it true that the time you have to wait in the line decreases? No. The more people in line, the more you have to wait. So again, this would be a positive association. Fourth one, as your time working increases, your amount of free time decreases. That is true, right? The more we work, the less free time we have. So that's a negative association. And then finally, as the speed you walk increases, the time it takes to get to your destination decreases. That's true. The faster you go, the less time it takes. Okay. Question 5. Katie surveyed all 7th and 8th graders at her school about whether they buy school lunch. Complete this two-way table. So key ideas here is that the rows and the columns need to sum together. So you will be allowed to use a calculator, but of course, good to be able to do this stuff without a calculator. So there's 293 7th graders total, and 219 of those bring a lunch. So if we're going to subtract that, then we will get that there are 74 7th graders who buy school lunch, and there's 219 7th graders who bring a lunch. Okay, we can do the same thing with the 8th graders. There's 261 total, and we know 168 of them buy a school lunch, so we can subtract that to figure out how many of them bring lunch, and that is going to be 93. And then we can add these up to get our totals. 74 plus 168, that's going to be 242 people who buy school lunch. And then if we do 219 plus 93, then we're going to get that there's 312 people who bring lunch. And then when we add these together, so in this case, when I say these, there's two possible ways of doing this. We can add these together, and that will give us the total, or we can add these together, and that will also give us the total. It's good to do both and make sure you get the same thing. So the total should be 554 students total in either version of adding these up. So we have 554 students total. Of those, there's 293 7th graders, there's 261 8th graders, there's 242 people who buy school lunch, and there's 312 people who bring lunch. Okay, all right, beautiful. Question 6.1. This relative frequency table shows the percentage of adults and children who prefer rides or games at a fair. Complete the segmented bar graph to represent the data. Use one bar for each row of the table. So a row is the horizontal, a row. So we're talking about adults and children. Okay, so here we're just sort of graphing this. They tell us to use like white for rides and then to like shade in gray for games. So for adults, we have 36% of adults prefer games. And so we don't know exactly where 36% is going to be. Going to be close to like half, in between 25 and 50, right? So this is like about 36%. Okay, and then the rest, the other 64%, we're going to shade in gray, and this is the 64% of adults who said they prefer games. Okay, so it should look like that. And then we're going to do the same thing for the children. We have 72% of children prefer rides, so that's going to be close to 75%, but not all the way there. And then that leaves 28% who say they prefer games, and we're going to shade in gray or whatever, with your pencil, the amount that prefer games, the percent that prefer games. Great. All right, that's all it is for that one. 6.2. This table shows the number of adults and children who prefer pizza or hot dogs. Complete the relative frequency table by row. Round to the nearest percent. Okay, so we are looking at, of the 153 total adults, right? How many of them prefer pizza? Or sorry, what percent of them prefer pizza? And what percent of them prefer hot dogs? And we're going to get our by row, so this horizontal percentages. So we're going to take 46 adults who picked pizza out of the 153 total adults, multiply by 100, and we're going to get about 30%. So we're going to say that 30% of adults prefer pizza. And then, based on that, that means that 70% of adults had to prefer hot dogs because there were only two options. But you could do 107 divided by 153 times 100, and that would give you about 70%. So that works too. Okay, and then we do the same thing for the children. 92 children out of 165 children said they prefer pizza. So we can do that part divided by the whole times 100 to get that is about 56% of children said they prefer pizza. And thus that means the remaining 44% of children said they prefer hot dogs, which we could also calculate by doing 73 divided by 165 times 100. It says round to the nearest percent, right? So we're not going to have anything after the decimal place, even though none of these percentages are perfect, right? I mean, like they're all rounded, right? They're decimals that are going on either forever or for a while. But we can round to the nearest whole number. Okay, great. Question 7. Pilar opened a hot dog store during the fall. She noticed that she sold more hot chocolate during colder days. For each day she sold hot chocolate, she plotted the points T, C. So T is like the x-axis independent variable temperature, and then C is like the y variable, y-axis dependent variable cups sold. First thing we do is we draw a line of fit for the data. So some line that's generally going through the middle of the points, about the same number of points above and below the line. You do want it to be like a line. I mean, I give you a ruler on the test if you want a ruler. You don't need a ruler for what I'm saying, but it shouldn't be touching all the points, right? It's like one line going through the middle. So something like that. Okay? And then we are going to, Pilar creates an equation of the line. So the equation of Pilar's line of fit is C equals negative T plus 120. And we're going to use this equation to predict how many cups of hot chocolate Pilar might sell on a day when the highest temperature is 32 degrees Fahrenheit. So she is giving us, or the problem is giving us, 32 degrees Fahrenheit. That is a temperature. And we're supposed to use that to make a prediction for how many cups of hot chocolate she'll sell. So I'm going to write this equation for the line of fit, and then I'm going to use it to make my prediction. So the cups are going to be equal to negative 32 plus 120, because I'm substituting that 32 degrees into the equation. And that is going to give me 88 cups of hot chocolate. So that's our prediction. That day, if it's 32 degrees outside, it's pretty cold. She's going to sell a lot of hot chocolate, specifically 88 cups. Okay, and then we can look at the graph and see if this like pretty much is aligned with what our line is saying visually. Right, so we go to like a little bit past 30. We go up here. We go over. Yeah, and it looks like that's around 88. But you do have to use the equation. So you can't just like estimate that that's like about 85 or 90, right? You got to use the equation. You have to show that you're using the equation. And then finally, we're going to explain the real world slope or rate of change of Pilar's line of fit. So what might be a little bit tricky here is we're using C and T instead of X and Y. And also the slope is kind of hidden. So the slope here is -1. Because when we have that negative X, right, the number in front of the variable that the variable is being multiplied by, right, that's going to be my slope in that M position. But we don't write a 1 often. 1 negative, like 1 times T is just T. So we're kind of omitting that. But our slope or our rate of change is -1 in this case. Right, and then we just have to explain what that means. The slope or the rate of change is saying when x increases by 1, this is how the y is increasing or decreasing by. So in this case, really, we're saying when the temperature is increasing by 1. So when the temperature increases by 1 degrees Fahrenheit, the model predicts that, and then is it the y variable, right? In this case, technically, it's the c variable, which is the cups sold, predicts that the number of cups sold will, is it increase or decrease here? Our slope is negative, so it will decrease by 1. So as it gets 1 degree warmer, the amount, they'll sell 1 less cup of hot chocolate that day, right? Because on average, people buy hot chocolate when it's cold out, and they're less likely to buy it when it's warm out. So the warmer it's getting, less hot chocolate is being purchased. You need to explicitly say, though, it's decreasing by 1, because that's the meaning of the slope for each 1 degree change. You can't just say, like, generally it's decreasing, because that's not being specific enough. All right, question 8, and then we are done. Amy surveyed some friends about whether they meditate daily and whether they are calm or anxious on average. The results of her survey are shown in the two-way table below. How many people total were surveyed? Okay, so this is a little tricky because sometimes they'll like have a total section here, right? And a total section here, but they don't. And then like this would be your total. So, I mean, you could create that, but you just have to add all of the things together because, yeah, that would capture it all. So like we have that there are 53 people who said they were calm when I add 45 plus 8. And we have that there are 44 people who said they were anxious. So then in total, there's 97 people that Amy surveyed. We could also see that by seeing that there are 68 people who meditate and there's 29 people who don't. So if you add those together, in total, there's 97 people. Okay, we could say how many people were calm and did not meditate. That is going to be right here in the table. There are 8 people that said they were calm and did not meditate. And then how many people total said they did not meditate? That's going to be this 29, right, that we found. So we just have to be able to interpret that table and add up as needed to find our totals. All right, good job, everyone. That's everything. Good luck.